Good afternoon. Welcome to GE. We are so pleased that you made the time to be with us here today. Are you managing your OR imaging dose? Well, we have something brilliant, and by the end of our presentation, we hope that you'll have discovered something that makes your OR imaging brilliant too. Surgical procedures move from open to minimally invasive, the need for intraoperative imaging emerged, and radiation entered the OR. And so did the concern over a dose. Now, unlike in diagnostic imaging, the unique aspects of the crowded OR and interventional environments challenge imaging. There are circulating nurses, surgical techs, and anesthesia. There's equipment moving in and out of the room, patient draping, and unique instrumentation in the field. Not to mention, the patient is undergoing a surgical procedure while being imaged. All of this and more pose remarkable challenges for achieving good imaging. As you know, dose isn't all that mysterious. It's a measure of the amount of radiation exposure times the length of the exposure. And lowering dose isn't all that complicated. Minimize the time of exposure and minimize the amount of exposure. Although the patient carries the focus of our attention in healthcare and receives the primary beam of radiation from a surgical C-arm, we can't afford to forget the effect of scatter radiation on surgeons and staff in the room during surgical and interventional procedures. As you can see from these scatter diagrams for both 9 and 12-inch OEC 9900s, the inverse square principle is dramatically in evidence, making distance still one of the best safeguards in reducing your dose. Even one step back from the surgical and imaging field can have a profound effect. Now, we've already seen the positioning challenges the OR can present. Maneuvering a C-arm up to the surgical field when there's staff and equipment in the room can be daunting for techs. Aligning the vertebrae for the perfect spine image or an IM rod for a long bone nailing often means repositioning several times and repeated exposures. With the OEC 9900 SmartView pivot joint, getting additional angles not available on a standard C makes this a snap. So as you can see, with the SmartView pivot joint, positioning is really easy. One of the easier ways to reduce dose in the OR is using the OEC 9900 Elite in our low dose and pulsed fluoro modes. With up to 1/2 the milliamperage in low dose, the operator can reduce up to 50% exposure. Applying pulsed fluoro whenever possible can reduce dose by up to 90% over standard fluoro, depending on a 1, 2, 4, or 8 pulses per second setting. Where some low dose technology can mean sacrificing a good image, the many image quality enhancements of the OEC 9900 means fewer sacrifices, which makes these options very attractive. Another impactful way to minimize exposure amounts is to activate collimation whenever possible. The OEC Iris, Dual Leaf, and cold curved collimators shield exposure with lead and tungsten shutters. Collimating and rotating on the last image taken with on-screen preview means that you can improve IQ through a smaller focus area and take fewer shots. Our rotating anode allows us to add specialized beam filtration to reduce patient skin dose while maintaining IQ. We are committed to ensuring the safe and effective use of our OEC C-arms, applying all of the principles of ALARA as low as reasonably achievable. The many built-in features that we've just reviewed today are designed to support you in that endeavor. Now, you can download this handy radiation safety guide from the GE Healthcare website or from iTunes. Thank you very much for being with us today to explore how you can achieve the right image at the right dose. It's brilliant.